Okay, guys, we're going to talk about our converse and inverse now. Do apologize, you'll probably hear the bell here in a minute, but I need to make sure that I got this recorded before the end of the class or the end of the day for anybody who's absent. So your converse and inverse are two other ways of writing your conditional statements. So remember our conditional statements. I'll come back up to this information right here in a moment. Your conditional statements are your if-then. You have your P, then Q. P being your hypothesis, Q being your conclusion. And we write it if, P, then Q. This is why when we talked about conditional statements, you cannot include the word if and the word then with your hypothesis and your conclusion. It's the words between if and the comma and the words after then. Because whenever we start transforming these conditional statements into what we call the converse, the inverse, and a couple other things, we need to make sure that we are not taking the words if and then. They're going to stay put, okay? And this will make more sense in a moment. Your converse is going to be, you're going to take your conditional statement, okay? So you're taking your original conditional statement, your if-then. All you're doing is you're switching that hypothesis and that conclusion. So rather than if P, then Q, you're going to have if Q, then P. So that's why we want to leave the if and the then there. The hypothesis and conclusion do not include those words, all right? Because we're not going to say then your conclusion if your hypothesis. That's not what we say. So that's why our hypothesis and conclusion do not include those words. Now, your inverse, you're going to take your conditional statement and you're going to negate both the hypothesis and conclusion. So again, you're going back to the conditional, your original. Now up here at the top, your negation is a statement that it's the denial of the statement. What that means is instead of if P, we're going to say if not P. And it's noted as the little squiggly line P. What the denial of the statement, all inverse means, guys, if you remember inverse operations in algebra, inverse just means opposite. So you're looking at your opposite. So if I say, if it is a bug, then it is a spider, to say the opposite would be, if it is not a bug, then it is not a spider. But again, you also have to remember these different things. Our examples here don't show this example, but if it is not a bug, your negation of that would be it is a bug, because you have to remember you don't say it is not a bug. Your negatives will cancel each other out. That's why we want to make sure we see this. Negation is going to mean the opposite. Okay? So here we have if squiggly line P, then squiggly line Q. So you still have your hypothesis and your first and your conclusion, but now we're saying if not P, then not Q. Noting that if it already says not, we need to remove it. Okay? Because you get double negatives then. And we'll see that whenever we talk about the November 2nd, 11/2 notes. So the nice thing here is they gave us P, our hypothesis is, and this is where the colors come in, you are a guitar player. And they give us Q, our conclusion, you're a musician. So we don't have to take the statement and create the conditional statement. We just have to throw the words if and then in there. So your conditional statement here is if you are a guitar player. So write that in. Sorry if my handwriting's sloppy. Try and do it fast. Make sure that you do pause. You need to. If you are a guitar player, comma, okay, there's our P. Remember that this is if P, then Q. Okay, here's our P. Then you are a musician. Giving us you are a musician as our conclusion, that Q. We also want to say if this is true or false. Well, if you play guitar, are you a musician? Yes. So this is going to be a true statement. And we'll talk more about the true and false statements in the next set of notes as well. So your converse, all we're doing is we're taking that P and that Q and they're just going to switch places. So here, instead of the P coming first, we're going to say if Q, then P. So this is where the colors really help out. So we see that not only the letters switch, but we can see me, I'm using pink and blue. So my pink and blue are going to switch. Okay, again, sorry if you are colorblind, but I know that a lot of the colors help a lot of the students, but you can look at the letters also. The Q and if you are colorblind, the Q and the P have switched. So now instead of if you are a guitar player, you're going to say if, we're going to take our conclusion, you are a musician. So if you are a musician, so there's that conclusion. Then your original hypothesis, you're a guitar player. I'm writing fast, it's making my handwriting really sloppy here. Remembering that when we're underlining, we are not including the words if or then. This is why. Because the if and then don't switch. The other words will switch. Okay? So we look at true or false. If you're a musician, then you're a guitar player. Does that happen all the time? No. We've got a false statement here. Okay? Counterexample. Examples that prove this is incorrect. You could be a drummer. You could be a tuba player. You could be someone plays a violin, a violinist, or whatever they're called. Okay, that's why I'm a math teacher, not even a music teacher, right? Your inverse, we go back to our conditional statement, the if P then Q, but we're going to do the opposite of the hypothesis and the opposite of the conclusion. So we have the negated P, then if not P, then not Q. So we still have the same order of those colors and those letters. We just have this negation sign. We're doing the opposite. So what this looks like, if we look at our original conditional statement, if you are a guitar player, well, what's the opposite of if you are a guitar player? You are not a guitar player. So we put if you are not. Or you could put aren't. They're the same thing. If you are not a guitar player, comma. So we have our hypothesis that are, the guitar player, but we added in that negation right there. So if you are not a guitar player, then, well, what is the inverse or the opposite of you are a musician? You are not a musician. If you always just remember that opposite, so that you are not a musician, now becomes our conclusion because when it's inverse because we have negated it. So if you're not a guitar player, does that mean you're also not a musician? No, that's a false statement because, again, if you're not a guitar player, you could still be a musician. You just play a different instrument. All right? The next three already have the conditional statement written for us. They're so nice to do that, so we don't have to worry about writing the conditional statement. So here we're going to rewrite the definition of perpendicular lines. It's already written as a conditional statement, and we're just going to take it and make it into a converse and inverse. So here your conditional statement, if P, then Q. So we have our hypothesis, P, two lines intersect to form a right angle. Very long hypothesis there. Then Q, they are perpendicular lines. No if, no then. Because the if and the then are going to say exactly where they are in the new statements. So your converse, all we're going to do is we're going to switch. We're going to have if Q, then P. So see, our colors and our letters have switched places. So we're going to take the conclusion, they are perpendicular lines, and we're going to add that word if in front of it. If they are perpendicular lines, again, sorry with the messy handwriting, but we're just copying it directly from above. If they are perpendicular lines, remembering that if we're using our colors, use your corresponding or matching colors. Your hypothesis, your Q was in, I put it in blue, so I'm going to keep it in blue, keeping that same exact color. If they are perpendicular lines, then we'll write out that hypothesis, their original hypothesis. Then two lines intersect to form a right angle. Sorry guys, somebody came into my door. So to reiterate where I was, then two lines intersect to form a right angle. Hopefully I did that correct. A little distraction. Somebody needs help. So here we've just switched our colors, we switched our letters, we switched our hypothesis and our conclusion. So with our inverse, now we're going to go back to our conditional P then Q, but now we're going to say if the opposite of P, then the opposite of Q. So we want to go back and say if two lines intersect to form right angle, what's the opposite of two lines intersecting to form a right angle? Well, yeah, honestly, it'd be parallel, but we'd say if two lines do not intersect to form a right angle. So we've got to enter that not, do not, don't, something in there. So we'll say if two lines do not intersect to form a right angle, comma, make sure you're pausing because I want you to be hearing what I'm saying, okay? So pause if you're not done. So then we're looking at what is the opposite of our conclusion. They are perpendicular lines. How can we say that that's the opposite? They are not perpendicular lines. Okay, so then they are not perpendicular lines. So here we have our hypothesis, two lines intersect to form a right angle, but we added in that opposite or negation, do not. And then we have our conclusion, they are perpendicular lines, adding in that are not, the negation, the opposite. I'm trying to rush through this video during my lunch, so I'll try to make the next one, my handwriting, a little bit prettier for you. So we have two more examples here. We're going to fill in the converse and then the inverse of these two statements here. Again, they've already given us our conditional statement. We have if P, then Q. Our hypothesis P, just an animal is a mammal, no if, okay? And then Q, our conclusion is just it breathes through lungs. So again, with our converse, all we're doing is we're switching these two around. So our conclusion will come, we're going to switch that conclusion to the beginning. So we'd have if it breathes through lungs. Okay, so that was that conclusion part, our Q. Then, what we underline is our hypothesis, our P, an animal is a mammal. Just underlining an animal is a mammal with that corresponding or matching color we use for P, our hypothesis. Again, pause please. Make sure that you're getting it all. I know I'm going fast, but I've got to make this video a little bit shorter. So our inverse, we're going to have the opposite or negation. If not P, then not Q. So we're going back to our conditional statement, where our hypothesis P comes first and our conclusion Q comes second, but we're going to do the opposite, the inverse. We're going to negate it. So if an animal is a mammal, what would the opposite of that be? If an animal is not a mammal, or you can say if an animal isn't a mammal. It does not matter whether you join that together or not. So here, if an animal is not a mammal, comma, I kind of keep switching this up. There's our P negated or given our opposite. And then we look at what's the opposite of it breathes through lungs. It does not breathe through lungs. So we'd say then it does not breathe through lungs. And it does not breathe through lungs, we'll underline with our conclusion color. Highlight that negated, that opposite. Pause it if you're not ready. Our last example here, we have our definition or conditional statement. If P, then Q. P, our conclusion, being not if, but two angles are complementary, that is all. Q, our conclusion, not including the word then, is simply going to be their measures add up to exactly 90 degrees. So first, let's do the converse, switch. So we're going to put the conclusion first after the if and our hypothesis second after the then. So we're just going to take those two and switch them around. So we're going to have if their measures add up to exactly 90 degrees. A lot of silence there, right? So just underlining their measures add up to exactly 90 degrees. Then put in that first part, P. Two angles are complementary. Not underlining the word then, just everything else, that corresponding or matching color. So again, with our inverse, opposite. We're negating here, so we're going to go back to our conditional, but we're going to negate, if not P, then not Q. All right? So we're going back to the original hypothesis first, then conclusion. So, but we want to make it opposite. So if two angles are complementary, what's the opposite? If two angles are not complementary. I'm just going to put the number 2. Comma. So there is our P. Two angles are not complementary with that negation. Make it at the opposite. Highlight the negation in. Forgot to do that on the other two as well. So I'm kind of going back, highlighting those negations. Okay, making sure they're sticking out. So if two angles are not complementary, then the opposite of their measures add up to exactly 90 degrees would be their measures do not add up to exactly 90 degrees. So then their measures do not add up, I'm running out of space, to exactly, there we go, 90 degrees. So there's our Q that is negated, or we have the opposite of it. How do we know? Because we have that not in there. All right, so hopefully this makes sense, and in the next set of notes we will cover taking it another couple steps further.